7 through 10 of the checkpoint. Okay, so on these, you're converting the numbers that are already in decimal and convert them over to scientific notation. So this is 423. We know that the decimal needs to go right here. And so in order to do that, we're going to be moving the decimal from here to here. So that's 2 positions. And since we're making the number, it's going from a larger decimal number to this part being smaller, we need to make up for that by having a bigger exponent. So it's going to be times 10 to the second power. All right, 2 million is the same as 2 times 10, 2 times 1 million, which is the same thing as 10 to the 6th power, right? And so we're taking the decimal place, we're moving it 6 positions here to get it to here. And since we're making this big number, a smaller number here, it gets made up in the exponent. So it's 2 times 10 to the 6th. And if you have questions about whether or not you did it right, whether it needs to be a positive or a negative exponent, just convert it back and make sure that you get back to where you were. All right, now, number 9. We're having a really tiny number. We're going to make it a bigger number by turning it into 1. We're moving the decimal place. How many places? We're moving 1, 2, 3, 4 places. And since this number is bigger, this number has to be smaller. So it's 1 times 10 to the negative 4th is where we're moving the decimal place. All right, and then lastly, another smaller number. We're going to have to move that 3 places. We're making this number larger than this number was, so it has to be made up, it has to be balanced in the decimal point by having a negative. And again, if you've got questions about whether or not this needs to be positive or negative, convert it back and make sure that you're going to, get the same number back. Just keep in mind, when you have a negative exponent, that means you're going to have numbers over here that are going to be under 1, right? That's like a fraction. All right, so I hope that that's clear. All right, so now let's go to the next section, which is going to be about doing some operations with scientific notation. And, so your exponent rules are going to come into play again. And so here, let's look at example 3A. All right, they have this number, 1.4 times 10 to the 4th power times 7.6 times 10 to the 3rd power. Well, I mean, this is really like saying, okay, this is just one string of multiplication, right? Because this is multiplication, there's multiplication here, all the way through. So if I wanted to, I could use the commutative property, right? And I could change the order that I'm doing the multiplication. I could say 1.4 times 7.6 times 10 to the 4th times 10 to the 3rd power, right? All I'm doing is I'm using the commutative property and just changing the order of multiplication, which I'm allowed to do in math. Now I want you to take your calculators and calculate this, 1.4 times 7.6. What's that? 1.4 times times 7.6. All right, this is equal to 10.64. And now we're going to do the times 10 part. Now you're going to use your exponent rules to figure this out. If I'm multiplying 10 to itself 4 times and 10 to itself 3 times, how many times ultimately am I multiplying 10 to itself? Well, it's being multiplied to itself 7 times. All right, now you might have noticed this part of the number now is no longer in scientific notation, right? Because I've got 2 decimal places here to the left. And so now I'm going to have to take this bigger number and make it smaller. It's got to become this, 1.064. So I've moved it once, right, to the left, and I got to make up for that here. And so that's going to be to the 8th power. Because this number is smaller, I've got to add 1 here if I moved it 1 decimal place here. Okay, so now my number is 1.064. So this makes, multiplying numbers kind of easy to just use those exponent properties, especially on this part. This part you're going to multiply the way you normally would. And then the last part is to do a little adjusting if you have to get it back into strict scientific notation form. Okay, now let's take a look at example 3B. Now we're going to do division. All right, and we have 1.2 times 10 to the negative 1 power over 4.8 times 10 to the negative 4 power. All right, just like the other part, you're still gonna do this part like you normally would in your calculator. You're gonna take 1.2 divided by 4.8. What is that? That turns out to be 0.25. And now you're gonna use your exponent properties for when you have a fraction. So 10 to the negative 1 divided by 10 to the negative 4, what are you going to do? You're going to subtract these exponents, right? So this is 10 times, this is negative 1 minus a minus 4, right? Negative 1 minus a minus 4, so that's like saying negative 1 plus 4, and that becomes to the third power, right? All right, is this in scientific notation form now? No, because I need to have one decimal place here to the left of the decimal, and I don't. So I'm going to take this decimal, it's a small number, and I'm going to make it larger, right? So that means I've got to make the exponent smaller here. So this is 2.5, and I'm going to subtract one power from this, and it becomes 2.5 times 10 to the second power. If you have any questions about whether or not you're doing it right, you could do this in your calculator. Make sure you get the right, if you do the decimal for each of these, that these are equivalent in fact. All right, and then let's do example 3B. All right, now we have a number that's in scientific notation, and it's being raised to a certain power. Well, this is just like your earlier properties where you'd say a to the m. You got more than one number that's being multiplied, and b to the m. Right? This would be like it's a, and that's like it's b, right? So what power is this for? It's to the first power right now. So this is the same thing as saying 4 to the third times 10. And remember, we got to multiply our exponents, right? This a to the m raised to the n, equals a to the mn. So negative 2 times 3, that ends up being negative 6. Okay, now, well, what is 4 to the third power? That's 4 times 4, that's 16, times 4, so that's 64, times 10 to the negative 6. So the question is this in scientific notation? And the answer is no, because you got 2 decimals to the left of the decimal place, and you need just 1. So we're going to take this big number, and we're going to make it smaller, which means that we're going to make this this bigger. So this is going to become 6.4. So that's going from a bigger number to a smaller number. So now that we got to make this be a smaller number go to a bigger number by adding 1. So this becomes to the negative 5 power. And if you've got questions about, did I do that right? Put this in the calculator, put that in the calculator. They better be equivalent. All right, now go ahead and do the checkpoint. And I'll see you in the next video to go over the checkpoint.